Programmer-defined functions, advantages and disadvantages. We've seen built-in functions at this time, keywords that MATLAB already knew. But before we move on to programming our own keywords, let's recap on the real advantages and the one disadvantage of functions. A function, whether it's built-in or programmer-defined, is a keyword that executes a task. But there is actual code hidden behind that keyword. While we've referenced it to magic, there is actually code. Imagine you wrote this code, and this particular function called menu creates this box. What makes it work? There is a way to actually see what's behind a keyword. Some functions are available by using the edit command. For example, the menu function has 5 pages of code. This now explains a lot why programmers have to be very careful when naming variables. We cannot name our own variables as existing keyword. The input is a function, which means there is a file behind it, called input specifically. So while we call the function the first time, MATLAB goes into the file, we can call it a second time, but if by mistake we call a specific variable input, then MATLAB loses that file. It doesn't destroy it, but it loses the direct link. And therefore, as soon as we try to use that file again, MATLAB no longer has access. It will crash. This also explains why we cannot name our variable identical to our file name. The name of the file is a keyword. If by mistake we choose a variable by the same name, MATLAB is confused. There are a lot of advantages to using functions. As you can deduce from the examples we just showed, shorten the code. We had one keyword menu instead of 5 pages of code, and reusability. We can type twice that keyword menu, and instead of 10 pages, we only have 2 keywords. But there's actually a lot more. Functions are used in every program that actually matter in the industry. Suppose a very basic EGR101 project, where you had to define a payload, select an orbit, calculate the fuel, the structure, the weight, the engines. Then you had to design the actual rocket, so size of the fuel tank and the geometry. Eventually, there's always a cost. Well, think about that in terms of programming. For example, at Huntsville, Alabama, these engineers are working on developing an exploration concept for space, so a rocket. Well, the client is always present somewhere. But as you can see all these people staring at computers, they're all working on their own specific code. These are all functions. One function is specific to the orbit, another one to the fuel, and so on. There are many advantages to working like this. The first one is focus. As you can see, each engineer is very devoted to their own task. They do not need to be involved in the entire project. They might be the one expert in their field. Independence. Instead of one script file, which is what we've been doing up to now, the software is divided into smaller files. There's actually a lot of advantages to this method. Various engineers can work on their parts simultaneously. But they can also develop code privately. They can even move. However, they can get again together to share pieces of code with other colleagues. Somebody else that's an expert on the topic can help you fix your little function. Or you can be hired by 2 companies and use the actual same function. If this function works for this rocket and the other one is similar, why not reuse it? So you can again see the reusability aspect. As far as technical ideas, it's memory efficient. If you think about one big, huge script file, it has many variables from start to finish. But if we divide this one script file into multiple little ones, what actually gets communicated from one to the other is only the important information. Think again about the menu function. If you look at the one script file that has this function call, right now there is only one variable used. But if you remember, there's 5 pages of code behind that. So there's obviously many variables in that code. But however, in our main code there's only one, which implies that the many variables used are actually deleted. Anything that is not important is deleted as soon as the function is done. It's also easier to debug. Again, big picture versus small picture. Would you like to debug 1,000,000 lines, or would you prefer focusing on maybe 100? Each function can be tested separately. It might require the programmer to assume values, of course, but it can be looked at individually, so it's very easy to debug. Clarity, we can move the code from the main program into a separate file, replacing with a single "this is what being done" command. That's the function call. And last but not least, modularity. If you have to fix a function, you don't have to fix the entire program. Think of the idea of a car. If your door breaks down, you don't want to replace the car, but you just want to fix the door. So that's the same idea as modularity. There is only one disadvantage to having functions. Every function is a separate .m file on its own, so that makes it a lot of files to keep track of. For example, this right there is one final project. The Excel sheets are in there, any .m file is in there, there is only one main code. The name is actually helpful. Run me indicates that this is the main file. So there's 8 advantages versus 1 disadvantage. The key points again are that a function is nothing but a keyword. It stands for a lot of lines of code behind it. If it's built in, the function came in with the MATLAB software. If it's programmer defined, which is what we're going to start learning, it means that you created your own keywords.